Hi everybody, Aaron with Bioacademics, and we're going to introduce these things that we call Newton's laws. So if you remember from science class and physics, I don't know if anybody ever stayed awake for any of those, but Newton's laws were essentially a three-part series on how an object and a force come together in order to create a motion. So in a sense, this first law of Newton was that an object, in terms of how much of the object was present, or its mass, if you will have a certain tendency to want to resist change in its position or change in how it's moving. So the typical definition that you might see or heard or have heard would be an object tends to remain at rest, or an object tends to remain in uniform or constant motion unless acted upon by some other force. So an example of that might be, we have this dumbbell here that has a certain amount of mass to it. Now with that mass, we also have a pull or a force being placed, let's try that again, on this object. And depending upon the amount of pull that's being placed on that object, we see that with a certain amount, we can create some motion. Now, given that the dumbbell had a certain amount of mass to it and we pulled it just enough to get it to start moving, we see that there's a certain amount of force that's required for motion of this dumbbell, and that increasing that force increased the tendency for it to want to move. So if we were going to relate force and motion of an object, and we'll just say given that that object is the same exact size, more force is tended to create more motion within that same object. Flipping that around, less force is less tendent to create a motion within that force. Less force is less tendent to create motion within that object. So there's a little bit more to that other than just amount of force and amount of motion in terms of how much change at any one time that there is in that motion. Now that's where Newton gets into with his second law.